Assalamu alaikum students. In our previous lecture, we discussed in detail about potential energy associated with a test charge Q in in a uniform point charge and several point charges electric field. Potential energy can be described on a unit charge basis, and we call this concept an electric potential or simply called potential. The calculations involving energies of charged particles and electric field become simple with potential. So potential is potential energy per unit charge. Potential energy is equal to. We can define the potential V at any point in an electric field as the potential energy U per unit charge associated with a test charge Q naught at that point. Potential energy and charge are both scalars, so potential is a scalar quantity. SI units of potential is called as 1 volt and it is equal to 1 joule per coulomb. Actually, unit of energy divided by the charge. We know the work done by the electric force during a displacement from A to B is equal to change in potential energy. Our previous lecture is about this. And now work per unit charge basis would be equal to so potential energy per unit charge is potential. VA means potential at point A and VB means potential at point B. The work done per unit charge by the electric force when a charged particle moves from A to B is equal to the potential at A minus the potential at B. Similarly, it's the same like we find potential energy in a electric field. So one more thing, this for calculations of potential energy, we also took 2 points A and B. So similarly for the potential calculations, you also choose 2 points and then find out the potential energy per unit charge between these 2 points along some path. So one more thing is that the difference VA minus VB can be written as VA. Now, V is called the potential of A with respect to B. We sometimes abbreviate this thing like VAB. Look into the order of the script. This is usually called potential difference between A and B, but it is little ambiguous until we specify which one is the reference point. In electric circuits, which we will study in the next chapters, the potential difference between 2 points is often called voltage, and the reference point is important there as well. So this VAB means the potential of A with respect to B equals the work done by the electric force when a unit charge moves from A to B. We can also understand it as the other way. UA minus UB is the amount of work that must be done by an external force to move a particle of charge q naught slowly from B to A against the electric force. So the work that must be done per unit charge by the external force is then UA minus UB over Q naught be equal to VA minus VB is equal to potential difference. So VAB is the potential of A with respect to B equals the work that must be done to move a unit charge slowly from B to A against the external force. And voltmeter is usually used to measure the difference of potential between 2 points. Now we can find the potential V due to a single point charge Q uh, by dividing it with potential energy. We know it V is equal to U over Q naught is equal to 1 over 4 pi epsilon naught Q2 or potential due to a point charge. Potential due to a point charge. Here R is the distance from the point charge Q to the point at which the potential is evaluated. If Q is positive, the potential produces is positive at all points. Q positive, potential is positive. If a charge is negative, it produces a potential that is negative everywhere. Next, potential is equal to 0 when the point of evaluation is at infinite distance from the point charge. So V is equal to 0 if R is to infinity. Note that potential is independent of test charge Q naught that we use to define it like an electric field. Okay, that's design go. Similarly, the potential due to a collection of point charges would be potential here Ri is the distance from the ith charge Qi to the point at which the potential is evaluated. Just as the electric field due to collection of point charges is the vector sum of the fields produced by each charge, the electric potential due to a collection of point charges is the scalar sum of the potential due to each charge. Okay. And in previous chapters, we calculate electric field for continuous distribution of charges along a line, over a surface, or through a volume. In those problems, we divide the charge in small elements dq and then we take the integral to find out the total contribution. Similarly, we can do it for potential. So potential due to R is the distance from the charge element dq to the field point where we are finding potential. So in the next lectures, we will work out several examples of continuous charge distribution with respect to potential, like we did in previous chapters with respect to different other variables. Also, the potential defined by these two equations, this one and your this equation, this one, these two equations, is zero at points that are infinitely far away from all the charges. Okay, let's move to the next video.